Hey guys, so today we're going to take a look at how to solve the second type of statics problem that you need to know about. And that is basically a table problem, as you see here. And so if this is the first time you're seeing it, that may seem like a lot. So maybe let's break it down for a bit. First of all, the questions here. You're asked to find F1 and F2, which are the support forces from the legs, respectively. So that says find F1 and F2, the forces provided by the legs of the table. I know the glare is kind of bad, you may not be able to see it, but that's what it says. So what else do we have? Well, here you see a dotted green arrow. This is the length of the table, okay? So our table is 6 meters in length, so it's an awfully big table. On top of our table, we have two different masses, mass A and mass B. Mass A is 1.5 meters from the far edge of the table. Mass B is 1 meter from this other edge of the table. Right around the center of the table, you see a circle. That circle stands for the CO. That circle represents the COM, by which I mean the center of mass. So the center of mass is located there. It's just at the table center. The center of mass will always be at the table center. We have very little time to spend on this stuff, so the circle in the middle will always be dead center. So COM is the center of mass, 24 kilograms. So that means the slab on top of the table is 24 kilograms. For our problems, the legs will always be massless. So the table's mass is 24 kilograms. So these two legs essentially support three different objects. And those objects have different locations. Our first leg is at the very end of the table, which kind of makes sense. Well, should make sense. The second leg is somewhere toward the middle, not quite at the end. It's 2 meters from the end. So this 2 meters is telling you how far this leg is from the end of this table. And then we have the numbers for our masses. So that's just a quick breakdown of what the problem looks like. All right, so from there, I'm going to need to copy this and keep it going on our next page. So I think at first glance, this seems like kind of an easy concept. Because to me, at first glance, all that I'm thinking about is forces. And if all we had to think about was forces, that'd be great. That'd be easy, and we've done this in like 30 seconds, and I would not have to put this video online. But as you'll see soon enough, that's insufficient. First of all, table's at rest, which means that the net force is 0 newtons. Things are at rest. So the up force is basically that. So the up force is equal to down forces. And this is a great place to start. But as we'll soon see, it's only a start. Okay, so what are the forces that act? Well, our up forces are F1 plus F2. Our legs have arrows that point upward, which tells us that the forces are up. This won't always be the case. But here it is. So the up forces are F1 and F2. So the up force is equal to down forces. Well, we have three different down forces. There is the downward force of gravity exerted by or on object A. So gravity pulls that down. There's the downward force of gravity due to the table, which I'll call FGT. There's thirdly the downward force of gravity due to mass B, which I'll call FGT. So this is our first equation, and it's helpful, and it's pretty straightforward. FGs are just mass times gravity, so that's cool and easy. So F1 plus F2 equals MA times G plus MT times G plus MB times G. And you should be able to, bust out that calculation, no problem. You take the mass of the C multiplied by the gravity. What you get is that the net downward force is equal to 392 newtons. Okay, so helpful. We can maybe call this equation 1 so you know what we're referring to when we come back to it. So this is helpful, and that's good, but it's not enough. Your first thought might be, well, okay, I have two legs, and I have this total upward force. So maybe I just divide by 2. So maybe I just say it's, you know, what, 186? Or I'm sorry, 196 newtons per leg. Just take that divided by 2, say that half the support comes from this and half the support comes from this, and just call it a day. That sadly would be wrong. Hopefully from looking at this picture, you can tell that most of the mass is concentrated closer to leg 2, our second leg. As a result, the second leg is going to have to provide more support force than force 1. How much more is the question? And so here we are sort of at, so it's sort of tricky here. So what do you do? Well, all right, I'm going to stop this video to make sure that it's working, and I'm going to start a new one from here. So see you in a sec.